Dividing radicals. So we have a property for the division of radicals. It says if you have two radicals that are divided separately, you can divide them underneath one radical. Now, this only works of radicals with the same index. So if there's a cube root on top and a square root in the bottom, you cannot use this property. So you're going to divide the radicands inside, so that means A and B get divided, and then you're going to divide any coefficients outside if you have them. So this is a way to simplify when you have a division of square roots or cube roots. We're going to focus mainly on square roots. So for example 1, 12 times the square root of 160 divided by 2 times the square root of 5. So what you could do is you could try to sit and simplify the square root of 160 and then work with this as a whole. But I noticed that I can actually divide 160 by a 5 evenly. So I'm going to use my property of my radicals to change this into a fraction. So we're going to divide the coefficients, 12 divided by 2 times, and we're going to divide the radicands, 160 divided by 5. So what happens is 12 over 2 makes 6 times the square root of 160 divided by 5 is 32. 32 is much easier to simplify than 160. So now that I have some smaller numbers, let's simplify this as a usual square root. So we're going to break up 32, 8 times 4. 8 gets broken down into 4 times 2, and 4 is 2 times 2, and this 4 is also 2 times 2. So we're going to look for our pairs, since it's a square root. So I have 2 pairs of 2's and 1 2 left over. So we end up with 6 that drops down times 1 2 from the inside and another 2 from the inside, and then the square root of the leftover 2 without a pair. So we have 6 times 2 times 2. 6 times 2 makes 12. 12 times 2 makes 24 times the square root of 2. That is using your division property to simplify a square root. Let's try one more. This also works with fourth roots. So because I have a fourth root on the top and the bottom of my fraction, I can use my division property. Because again, 1,250 is going to be a little crazy to try to simplify. So let's use our property. So we're going to divide the coefficients, and we're going to divide the radicands. So 1,250, that's the fourth root. 1,250 divided by 2 is equal to 625. So we have 4 times the fourth root of 625. And again, 625 is much easier to simplify than 1,250. So we're going to break down this 625 into 25 times 25. And then I can break each of these 25s down into 5 times 5. Because we have a fourth root, I want groups of 4s, and I luckily have 4 5s. So this is going to turn into 4 from the very, very beginning times the 5 that comes out, then the fourth root of whatever's left without a pair. But since there was nothing left here without a pair, this fourth root is actually just going to drop off. And all we have is 4 times 5, which makes 20. You can also use this backwards. So I can't simplify 32 over 81. There's no way to do that. There's nothing to divide both of those by. So I can actually use my quotient property to split this apart as well. I can split this into the square root of 32w over the square root of 81. This helps me out because I know that the square root of 81 is actually a perfect square. The square root of 81 is equal to 9. Now what we have to worry about is simplifying the numerator. So I'm going to come to this side, and I'm going to simplify my numerator, square root of 32w. 32 breaks down into 8 times 4, 4 times 2, 4 breaks down into 2 times 2, this 2 breaks down into 2 times 2, and all I have is a single w. So since this is a square root, we're going to go look for pairs. So I see 2 pairs of 2's. and I don't have a pair of w's. So this 2 and this w must stay under the root. So I'm going to have 2 times 2 times the square root of 2w. 2 times 2 makes 4. This is your new numerator. So what this turns into now is this will turn into 4 times the square root of 2w. That's the new numerator, all over 9. Since I cannot simplify 4 over 9, this is as simple as this expression is going to be. So you can use your form both ways. Now, rationalizing the denominator. So we cannot leave radicals in the denominator of a fraction. It's not proper. So to get them out, we do something that we call rationalizing the denominator. So if you have a monomial, so what that means is there's one term in the bottom and it's a square root. Multiply the numerator and denominator by the radical to get rid of it. Now, if it's a binomial, something like 2 plus square root of 4, 3 minus square root of 5, any of those are binomials. A monomial would just be square root of 6, just a square root. So if you have a binomial, you're going to multiply the numerator and the denominator by the conjugate. So the way you find the conjugate is you actually just take the same expression with the opposite middle sign. So for this first little example here, 2 plus square root of 4, your conjugate is actually 2 minus square root of 4. For the bottom example, 3 minus square root of 5, your conjugate is actually 3 plus square root of 5. The only difference is the sign in the middle. One's positive, one's negative. Let's try an example. So for example 4, 3 over 2 square root of 5. So in the denominator, I have a square root. I need to simplify first if possible, but in this case, 3 over 2 does not simplify, and neither does square root of 5. So what we're going to do is we're going to multiply both the numerator and the denominator by this radical. The 2 is not the problem. This is okay. This square root of 5 is the issue. So we're going to multiply top and bottom of my fraction, because I have to multiply by 1 to not change my problem, by the square root of 5. So this turns out to be 3 times the square root of 5 over 2 square root of 5 times square root of 5. So let me show you how this simplifies. So we're going to use our multiplication property to simplify this piece down here. So the numerator is going to be 3 square root of 5 over, but the denominator changes to 2 times the square root of 5 times 5. Well, 5 times 5 makes 25, so square root of 25. And I know the square root of 25 is just a 5. This is really 2 times 5, which makes 3 square root of 5 over 10. That's how we get rid of a radical in the denominator. So the shortcut is the square root of a number times the square root of a number. Those two square roots will actually cancel each other out, and all you're left with is a single of that number underneath. That's the quick way to do it. Let's try some more. Example 5. Square root of 8 over square root of 15. So I need to see if I can simplify this first, and we need to make sure that we don't have any radicals left over in the denominator. So I can't do anything with 8 over 15, so I'm going to use my division property to split this apart. So this will be square root of 8 over square root of 15. Square root of 8 I can simplify, so let's go ahead and do that before we start with trying to get rid of the radical out of the denominator. So square root of 8, I can break that into 4 times 2, and 4 is 2 times 2. So here's a pair of 2's. So square root of 8 is actually 2 times the square root of 2. That's this guy left over. So what we have now, our first simplify process, is 2 square root of 2 over the square root of 15. Now square root of 15, you cannot simplify any further because it's just 5 times 3. There's no pairs there. So now we have to worry about getting that square root of 15 out of the denominator. So we're going to multiply the numerator and the denominator by the radical we want to get rid of. So on the numerator, I have 2 square root of 2 times the square root of 15 over square root of 15 times the square root of 15. So we're going to use some shortcuts here. So let's use our multiplication property. So 2 square root of 2 times 2 square root of 15 is going to be 2 square root of 2 times 15, all underneath. Then this is what we had on the other side. Square root of 15 times itself, these square roots are going to cancel, and all you're left with is a single 15. Now, let's clean up this numerator. 2 times 15 makes 30, so 2 square root of 30 all over 15. Now, I know square root of 30 is not going to simplify because it was made up of a 2 times a 15. 2 can't be simplified, and 15 is only 5 times 3, so there's no pairs in here, which means 30 will not be able to simplify either. And then I cannot simplify 2 over 15. 3 square root of 12 over 4 square root of 7. Okay, so square root of 12, you could simplify that down. So let's go ahead and work on simplifying my numerator before I start. I don't have to use my division property because if I tried to, 12 over 7 is not going to simplify. It's not going to make my life any easier. So 3 square root of 12, I can break 12 into 4 times 3, and I can break 4 into 2 times 2. Here's a pair of 2's. So we have the 3 from the outside times the 1 pair of 2's on the outside, which is going to make 6 times the square root of the 3 that's left over. So what we now have is we have 6 square root of 3 over 4 square roots of 7. So now we need to worry about getting the radical out of the denominator. So we're going to multiply the numerator and the denominator by square root of 7 to get rid of it. So our numerator becomes 6 square root of 3 times square root of 7, and our denominator becomes 4 square root of 7 times square root of 7. So in the numerator, 3 times 7 is going to be 6 square root of 21 underneath. Now square root of 7 times square root of 7, that's just a 7. So on the denominator I have 4 times 7, which makes 6 square root of 21 over 28. Now let's make sure we can't simplify anything. 21 underneath the radical is not going to simplify because 21 came from 7 times 3, and both of those are prime. Now 6 over 28 will simplify. I can divide both of those by a 2. So I'm going to divide the 6 by 2 and the 28 by 2. Which is going to leave me with 3 square root of 21 over 14. Now 3 and 14 can't be simplified further, so this is as far as this expression will simplify down. We're going to skip example 7 and go straight to 8. So we have 4 over 4 plus the square root of 2. So now I have a binomial in the denominator, so I need to figure out how to get this radical out from underneath. Now the difference is, since this is a plus, this 4 and this square root of 2 have to stick together. I can't just ignore this 4 like I did with the multiplication. This is stuck. So this is where we're going to multiply by that conjugate. So we have to think the conjugate is going to be the exact same expression with the middle sign changed. So since this underneath is 4 plus the square root of 2, our conjugate is going to be 4 minus the square root of 2. So we're going to multiply, I'm going to rewrite it so I have some space, the original by this conjugate on the numerator and the denominator. You're probably thinking, how is this going to help? Well, let's find out. So now for the numerator, we have a little bit more complicated problem. I have a monomial times a binomial in the numerator, so this is just straight distribution. So we've got 4 times 4 makes 16. 4 times the square root of negative square root of 2 makes negative 4 square roots of 2. But in the denominator, I have 2 binomials multiplied together. So we're going to have to do double distribution. 4 times 4 makes 16. 4 times negative square root of 2 makes negative 4 square root of 2. Square root of 2 times a positive 4 makes a positive 4 square root of 2. And the square root of 2 times negative square root of 2 makes a negative 2. Because remember, the square root of 2 times a square root of 2 That part cancels, and all you're left with is a 2. And then a positive times a negative makes a negative. So let's try to clean this up a little bit. Let's try to combine like terms. So on the numerator, there are no like terms to combine. But in the denominator, I see I have a -4 square root of 2, and I have a +4 square root of 2. So because they both have square roots of 2, these are like terms. So -4 plus 4 is equal to 0. So I have 16 plus 0 square roots of 2 minus 2. Well, 0 square roots of 2, well, 0 times anything is going to make a 0, so that we can ignore. So I have 16 minus 4 square roots of 2 over 16 minus 2. Well, 16 minus 2 makes 14. Now, last piece you need to check is you need to see if these three numbers can be all divided by something. So I see a 16, a 4, and a 14 all can be divided by a 2. So I can simplify, I can reduce this giant fraction. 16 divided by 2 makes it 8, minus 4 divided by 2 makes 2, square roots of 2, all over 14 divided by 2 makes 7. Now, yes, 8 and 2 can be divided by 2, but because you also have a 7 down here, you have to make sure you can divide all three. So since my 7 is not divisible by 2, this is as simplified as this expression is going to get. Example 9, 2 over 6 minus a square root of 5. So this is another place we're going to have to use the conjugate. So the conjugate is the same expression with the opposite sign in the middle. So in this case, we're going to have 6 plus square root of 5 multiplied to the numerator and the denominator. So again, the numerator is a simple distribution. 2 times 6 makes 12. 2 times square root of 5 makes 2 square roots of 5. Denominator is going to be a double distribution because we have a 2 terms times 2 terms. So 6 times 6 makes 36. 6 times square root of 5 makes 6 square roots of 5. Negative square root of 5 times a positive 6 makes a negative 6 square root of 5. Then square root of 5 times square root of 5. First of all, negative times a positive makes a negative. Square root of 5 times the square root of 5 is just equal to a 5. So that is here. Then combine like terms. So in the denominator, I have 6 square roots of 5 minus 6 square roots of 5. So those are going to add to 0. Then I have 36 minus 5, which makes 31. So we have 12 plus 2 square roots of 5 over 31. And again, check and see if you can simplify. 12, 2, and 31. All three of those are not divisible by the same number. So we are finished as far as simplifying. And final example. 5 minus square root of 5 over square root of 5 plus square root of 3. So now there's two radicals in the denominator combined by an addition sign. So we still have to think about a conjugate. So the conjugate is always the same expression with the opposite sign in the center, even if there's two radicals. So my conjugate for this example will be square root of 5 minus square root of 3. Same expression, opposite sign. So we're going to multiply that by the numerator and the denominator. Well, we actually have double distribution on numerator and denominator for this example. So let's just worry about the numerator. So 5 times square root of 5 is 5 square roots of 5. 5 times negative square root of 3 is a negative 5 square roots of 3. Negative 5 square root of 5 times square root of 5. Well, negative times a positive makes a negative. And remember, square root of 5 times square root of 5 is just going to give us a 5. So that's this answer to that part. Negative square root of 5 times the negative square root of 3. Negative times the negative makes a positive. Square root of 5 times square root of 3. Now let's do the denominator double distribution. We'll clean all this up in a second. So we're going to double distribute on the denominator as well. Square root of 5 times square root of 5. Again, that's this rule here, which just makes a 5. Square root of 5 times negative square root of 3. Positive times a negative makes a negative. Square root of 5 times square root of 3. Then we have square root of 3 times square root of 5. I'm going to go ahead and put them in the same order as the other one. Then square root of 3 times a negative square root of 3. Positive times negative makes a negative. Then, same idea as the square roots of 5. Square root of 3 times square root of 3 is just going to give us a 3. Now that everything's been multiplied, let's go kind of try to combine up what I can. So in the numerator, I need to simplify these things down. So I cannot actually add these two together because they do not have the same number underneath the radical. So these are going to be stuck the way they are. 5 square root of 5 minus 5 square roots of 3. Minus 5 does not have a like term yet, but I can simplify this piece of multiplication. I'm going to use my multiplication property to multiply 5 and 3 underneath the radical to make it a 15. Let's try the denominator, see if I can clean this up. So we have a 5. I'm going to use my multiplication property here, minus square root of 15. My multiplication property here, plus square root of 15, minus 3. So in the denominator, I see that I have negative root 15 and a positive root 15, which are going to add up to a 0. But I can also combine 5 minus 3 to give me a 2 in the denominator. Now the numerator, let's see if I can make anything combine. Well, this is square root of 15, so this is square root of 3, square root of 5. So none of these square roots are going to combine. And then all I have is this minus 5 without a radical, so this doesn't have a like term either. So my numerator is actually as simple as it's going to get. I cannot make your numerator any simple than it is because there are no like terms. So we have done what was asked, we simplified, and we made sure all the radicals were out of the denominator.